A couple months ago, a bacterial infection spread through the Midwest, infecting dozens and dozens of children. The source? Adorable puppies. Adding injury to insult, this infection was antibiotic resistant, so over 30% of the victims had to be hospitalized. So how do we fight infections like this? I mean, they're antibiotic resistant, right? Well, I think we can learn from another fight we've had in medicine, namely the war on cancer. And I think if we've learned anything from the war on cancer, it's that early detection is key. That way, we can kill the infection before it gets tough and antibiotic resistant. So let's think about how we detect infections now. Well, I had strep throat a few dozen times as a kid, so I can tell you exactly how we do it. First, take a wooden tongue depressor, and you depress the patient's tongue, you swab the back of their throat, throw that onto a petri dish, grow it up for a few days, and run some tests. This is a pretty uncomfortable process. I can't eat popsicles anymore. But what's worse is that couple of days. If a patient is really sick, a couple of days can be the difference between life and death. There is a better way, and it goes back to the puppies. You can actually train a dog to smell when someone's getting sick. They can do this because bacteria produce unique molecules that people don't. So you can train the dog to tell you when it smells one of these molecules. You know, hey, woof woof, you're getting sick. But dogs aren't a very scalable medical device platform, right? They're hard to interpret and super expensive. So we'd like a computerized version of a dog's nose. And we scientists would call this a sensor. And I'm in the sensor business. I shoot light at these molecules, smashing it into them, and I look at the light that comes out of these collisions. Through this, I can fingerprint exactly what molecules were involved in these collisions. So I spent the first few years of my PhD developing a nano-manufacturing method to make these light colliding sensors over a large area. Then, I showed we could use it to detect bacteria. To do this, I flowed fluid over a contaminated surface, and I sent this fluid to my sensor, and I measured it. I found that I could detect bacteria within hours of its contamination, way earlier than other methods. But I wanted to take it further, and to do this, I thought back to the dogs. You see, dogs have this big, beautiful brain to interpret their nose signals, and that makes them a lot better than my sensors. So now, I study artificial intelligence to make my sensors more like a dog's nose. With AI, now I can tell you not just which bacteria you're infected with, but also what antibiotics that bacteria is resistant to. I think my research will open new doors for the stewardship of antibiotic treatments.